So today we will discuss about queue. And what is queue? Queue is a linear data structure where insertion and deletion operation can be performed with some fixed from at some fixed position. That means suppose there are a number of items, a number of items in the list. Now the first item is called to the front of the queue, and the last item is called the rear of the queue. So queue means the items will be added or inserted only at the rear end, and the items deletion operation can be performed only at the front end. So in a queue structure, there will be two pointer. One pointer is pointing to the first node, and which is called the front, and another pointer is pointing to the last node in the list, which is called the rear. And when we are performing the insertion and deletion operation, that unlike linked list where deletion insertion can be done either at the beginning of the list or at the end of the list or at any intermediate position of the list. But in case of queue data structure, the insertion can be done only at the last end, which is called at rear end. We can do the addition, and the deletion is possible only at the front end. So it's just like a when suppose you were consider a queue of ticket counter. The first one who has been the first person who has inserted into the queue first, they will be serviced. They will get service first, and the front person only get the service. Then front will point to the next person, so next person will get the service. And only when new person will be added, they can't be added at the front of the queue. They always be added at the rear end of the queue. So that is the concept of queue. Now how to represent this queue? So in case of queue data structure, we need two pointer, y pointer. One pointer is pointing to the starting of the queue, which is called front pointer, and the last end is called rear, and we will use a pointer which will point to the rear node of the list. The front pointer pointing to the front node of the queue, and the rear pointer will point to the rear node of the queue. So here the insertion and deletion operation were to be done at throughout the length of the list, where the insertion and deletion can be done, that is totally fixed. So that is the concept of queue data structure. But when we will implement this queue data structure, so how it can be implemented in computer? Either we can use array to represent a queue, or we can use linked list to represent a queue. So in case of array representation, there is some method, or the implementation is some different than the representation which is done by the linked list. The difference, what is the advantages or limitation of this two representation? When we represent a linked list, a queue by linked list means the first node will have the data part, and the two parts will be there for every node in the queue. The first part will give the information about data, and the next part, that is second part, will point to the next node in the queue. So when it is implemented using linked list, there is no limitation that how much queue can be grown. But in case of array, there is a fixed size of array. So you cannot, if you want queue to be more, the size to be more than the fixed size of the array, then it will create a problem in case of array representation. But in case of queue, when represented using linked list, there is no limitation that how much the queue can be grown, because in linked list, that is the inherent advantage of linked list over array. And as we are using linked list to represent a queue, so we got all the advantages that was in case of linked list that will be inherited in case of queue also when it is represented using a linked list. So in this lecture, what we will see first, we will get how this. Yeah, we will see how to represent a queue using our linked list. Okay. Then, obviously, because the linked list implementation of queue is done in C language, then we will perform the insertion and deletion operation of the queue, and this queue implementation is fully written in C program. So first we will see how this insertion and deletion are performed. First we will see is diagrammatic view, how this insertion at the rear end has been done or how deletion from the front end has been done. That first we will see the diagrammatically how it is being done. Then we will convert that diagram to the C code for insertion function and for deletion function, etc. So first I will see how this insertion operation and deletion operations are performed. Then we will write a function for inserting and for deletion operation on the queue. And then we will execute or run this program on machine. So to see whether output is properly, whether we are getting the properly output or not, or whether the queue has been implemented successfully or not. That will be confirmed after implementation in machine. And this throughout total process is done based on C language. So first of all, we will go to the diagrammatic, conceptual idea about queue and how the operation and deletion to be done. When this concept from this diagrammatic view, we will convert it to C code, and next we will run this C program on machine. Okay. So today we will implementation of queue. We will implement queue implementation